السلام عليكم.
شايفينها شايف.
Can you see my screen?
واضح
Yeah.
حضرتك.
هلا طلعت.
طيب. So last time I posted several announcements and topics in the e-learning. The first one, how to write a scientific paper. So if you click on that, you can find useful information about how to write a scientific paper, starting from title to the abstract, introduction, material and methods, how to organize the tables, the graphs, how to discuss the results, and how to organize the references. Now, this, let's say, summary will help you in writing your, let's say, research work, either in this course or in the future. So I need you to go through this one later on and read how you can write a scientific research article or paper. This is the first thing that I need to announce for you. Now, the second thing here is topic selection. I posted in the e-learning like a selections in order to select a topic. Now, before selecting a topic, let's discuss with you the topics that we need to cover in this seminar. I will share with you my, okay, let's write everything here. Okay. I'm sharing now black screen, yes? Can you see it?
Yes. Yes.
Yes.
So
Yes.
this is the EE790, which is the seminar, correct? And you know the seminar is not classical course. It's actually 1 credit hour course to help you in order to determine your research, let's say, path, and help you to find a research topic, how to find a research topic, how to discuss your work or your findings in scientific manner. So the first thing here, I need you to select topic from the following. Now, the first topic here is actually a virtual synchronous generator. Plus Droop control. And the first paper I posted in the e-learning is mainly a comparison of transient angle stability between a virtual synchronous generator and Droop control. Simply here, the meaning of the virtual synchronous generator is that we need our voltage, a source inverter, to act as a synchronous generator. In order to support, let's say, the weak grid. So this is the first topic. The second topic is, let's say, synchronization, grid synchronization. Under abnormal grid condition. using a PLL, a phased locked loop. So this actually we can write it here, phase locked loop. It's PLL. This is the second topic. Now, in general, if I need to connect the voltage source inverter to the grid, I need to know the grid information. So the grid information must be known, let's say. And do you know what the meaning of the grid information is? What? Huh? Anyone know about the grid information? Such as the frequency, the amplitude, and the phase. This is very important when you need to connect a converter to the grid. You must know the grid information. And you can find the second paper in the e-learning. We'll discuss the grid synchronization. The third topic is mainly concerned in transformer-less inverter. Transformer-less inverter. And it's actually a multi-level inverter. You can see what I'm writing, yes?
Yes.
So transformer-less inverter, which actually a multi-level inverter. Now you know that it's recommended to connect the voltage source inverter to the grid via transformer, and the transformer actually will provide what? Will provide the protection, correct, to the converter, because this is isolation. Huh? Simply here, the transformer can be used for what? Can be used for either leveling the voltage and the current, and also for isolation. And if we have here any DC component, it will never appear here, correct? Why? Because here we have transformer, and you know the transformer only will transfer what? Alternating signal, not a DC signal, correct? Yeah. So the alternating signal will transformed, either leveled up the voltage or the current according to the turn ratio of the transformer, but the DC will be blocked. But now in this topic, in order to reduce the cost, this is for cost reduction, and also for the size reduction. Now, most of the commercial inverter are using transformer-less inverter, which means that there is no transformer, and now the inverter is connected directly to the grid. Good. This is the third topic. Now, the fourth topic is mainly for the variable weather maximum power point tracking. Now you know that the weather condition all the time is changing, which means that the temperature and the irradiance are not fixed, let's say. And this will put stress on the maximum power point tracking. This stands for maximum power point tracking. So simply here, what we need is to study MBBT under non-uniform weather condition. The fifth, let's say, how many are you, by the way? According to my participant here, you are 6 students, correct? So I need 6 topics. So the fifth one, so the fifth one is the grid synchronization, but without a phase lock loop. So it is a PLL less grid connected converter. So here the synchronization is done without PLL. This is very interesting, by the way. Now, the last topic that you can choose from is a high gain, a transformer-less DC to DC converter. So it is high gain transformer-less DC to DC converters. Now, from topic 1 to topic 6, 1 to 6, actually, it will cover power electronics, it will cover control, it will cover power system. Yeah. And all of the topics, I think, will be useful either to highlight or open the door for you to select your research topic in the future, or at least will pave the way for you to find a topic either related or close to the 6 topics that's listed here. Now, do you have any question before, let's say, distributing the topics upon you? No one. Taqwa, you are the first one to join.
Yep.
Which topic you are choosing?
Okay, I prefer topic 4.
4. So can you please log into the e-learning and check the 4? And here I will write Taqwa for the 4. So
Okay.
4 variable weather and BBT, and this will be Taqwa. And I will write it Taqwa. Correct the name?
Okay.
And this is already picked for what? For Taqwa. Okay. And please go to the e-learning and pick it there. Now,
Okay.
the next one. The next one is Lu'ay, because he's the next one to enter, correct? Lu'ay.
Topic 1. I will choose topic
The
1.
first topic is for Loai. So here I will write also in Arabic, Loai. Yeah. And this topic now is already for Loai. Okay. And now also in the same, go to the e-learning and click on the first topic. And now we with Muhammad Idris Fatah al-Bataini. I think you can select whatever you want, Muhammad. Muhammad?
Yeah.
Which topic? And one is picked, 4 is picked.
I think that like the last time, BLL.
You mean 2 or 5?
2.
2. So this is already now for Muhammad al-Fatih. Idris al-Bataina. And you know that this is only his first name, huh?
Yeah.
Okay. So this is now booked for Muhammad al-Fatih Idris al-Bataina.
دكتور
Okay.
الخيار نفسه مش موجود على الإيليرن.
The second one.
ما في
An
محل.
improved hybrid pre-filter open loop algorithm for 3-phase grid synchronization, man.
Yeah. The
Now,
same?
yeah, it's the same. It's grid synchronization, but simply here I'm specifying the method for you. Okay? Good?
Good.
Now, we end up with the three, let's say, topics to be selected by, let's say, Hanadi and Ibrahim al-Zabi and Muhammad al-Mahasis. Yeah? Okay. So now, they will pick later on. Huh? Okay. Another thing I need to highlight with you, that in the e-learning, for each topic, I think there's you can copy the title. I will share that for you. Okay, let me share my what is it? Here. Window, no, desktop, Microsoft. Okay, let's say desktop. Now you can see the e-learning, correct? Yes.
Yes.
So simply, if you select the first one, copy it. Let's see. I will try to copy it now, and put it or search for it on Google. You can find the first one is your paper. So this is actually the first choice, comparison of transient angle stability between virtual synchronous generator and loop controlled inverter. So you can download it from the account of the university. I think the university has account for that. Otherwise, if not, I can provide it from my account. The same thing here. If I go to the second topic, which is an improved hybrid B filter, I will copy it, post it, and let Google provide me with the link to download. Yep, the same thing for all the other topics. The first one, the second one, the fourth one, for example, which is the variable wither parameter MPPT control strategy based on MPPT constraint condition of PV system with inverter. Copy it, post it, and you can find it. This one in Sense Direct, Elsevier. Yeah. Good. Fair enough until now?
Yes.
Yeah.
Okay. Now, what else I need you to do? Now, not only you should download the paper that is directly related to your research, but also you should do like to collect, download all the papers related to your topic. So from 2016 until up to now, to the present, you should use either the IEEE Explorer or the Elsevier, or you should use the Science Direct, let's say. Yep. So either to use the or the Science Direct, which is the Elsevier. So for that, do you have a Dropbox account? I think you have a Dropbox account. If yes, you should create a folder and put in this folder all the related research paper. Good. And share this folder with me. This is my email address. Yes, Madi adjusted to do the job.
اللي بتكتب عليها مش واضح، قصدي مش ظاهر أمامي.
Okay, so let's share. I did not share it.
No.
Okay, let me try to fix this one. This is one now.
Yep, now it's appear.
Yeah. So the first thing is to collect all the related research. The second thing is to create a folder in your Dropbox. The third thing, to share that folder with me. So all communication, simulation, must be uploaded to your folder. Good. And simply name this one by your student number. I think this will be better. Yes? Good. Now inside it, create a readme text and write here your topic. Good. So simply, for example, Muhammad Riz will say that my topic is 2, which is a grid synchronization under abnormal condition. Good. So when I need to check your progress, for example, I can go to the folder and I know that you are, or I know your topic from the README file. And in the README file, you can write any message. You can write any message, note, or guideline for simulation. If you need me to run a simulation, you can guideline me, which means that you can guide me in order to, the first thing, please upload the first folder, run the first file, then upload the simulink, for example. Okay. Yes. So simply now I need each week a progress report. Which can be written in the README file. So simply, for example, you can say in week number 1, topic is selected, several papers are downloaded and start to be read. For example, week number 2, you will say that, for example, start simulation. Or let's start simulation of the selected paper. And so on. Understood? Understood?
Yep, Doctor.
Okay.
Yes, sir.
Yes.
Okay. Now, from time to time, I will invite a guest speaker. So from time to time, guest speaker will be invited in order to give a short presentation, either regarding a hot topic in the area or regarding their research work. So to present their research or highlight some hot topics in the area. Now, for that, I will give you announcements on the e-learning. So for that, an announcement will be posted on the e-learning. Good. Yes.
Yes, clear.
Yes.
Okay, now we have Ibrahim Azabi. Ibrahim. Ibrahim, where are you? Ibrahim. There's no Ibrahim. I think Ibrahim is here. Maybe he has problem with the mic. Do you have it? If yes, send a message. If you have problem with the mic, please send a message. Okay. Now, let's see. Okay. Do you have any question?
دكتور
مم.
بالنسبة يعني للبيبر هاي اللي بحثنا عنها قبل شوي اللي هي اسم الموضوع،
Yeah.
يعني هاي تكون البيبر الأساسية تاعتنا اللي نشتغل عليها ونعملها سيميوليشن، ولا يعني هاي
This will be your main paper if you fail to find any other paper related to the topic, which means that I'm giving you exit way if you cannot make your mind in selecting a topic or selecting, let's say, a paper. I'm selecting one for you. Good?
good.
But as I said, you only allowed to download the paper from IEEE Transaction or from Elsevier journals. Any other question? No? So, in the end, what I need you to do. So, you will, let's say, select a paper. Then you will simulate the paper. Then you write a report. So for that, I posted for you instruction how to write a scientific paper. Good. And last but not least, you should present your results. Yeah. And full stop here. Good. Still we have problem with Ibrahim, or he did fix the problem? Ibrahim, you are muting yourself. Release the mute. Ibrahim, I cannot hear you. Okay. Anyway, I did record this lecture, let's say, so you can return it. You can return to it, and simply you can select a topic from the remaining topics, because already Loai, I think, and Muhammad and Taqwa are booking 1, 2, and 4. So now the remaining topics are 3, 5, 6. 3 is about transformerless inverter, multi-level inverters. 5 about PLL-less grid connected converter, and I think I will give this one for let me see, for Hanadi. I will give this one for Hanadi. So now we have what? We have high gain transformer-less DC converter, and we have transformer-less inverter multi-level. Okay, so I will give this one for Ibrahim. And last but not least, I will give this one for Muhammad. Yeah. Now what we have here is Muhammad Al-Mahasis. So this one will be for Mahasis. Good. Yeah. Now, do you have any question? Do you have any question? So, we will meet next lecture, in which so until that time, you should select your, or not selecting, let's say, show me at least your downloaded paper. Collect the related paper. So before the lecture, you should upload the papers to your folder so I can see it before the lecture. Okay?
تمام.
تمام. اوكي. في عندكم اي سؤال؟ نو؟ تقوى.
نعم دكتور.
understood ايش بدك تعمليه؟
يب.
good. لؤي.
Yes, that's clear.
طيب محمد بطاينة.
نعم دكتور.
And Ibrahim Zoumi, just unmute yourself and I know it's clear for you. And next time, please solve the problem, huh? Okay, so this is the end of this meeting. Let's say I will not call it lecture. So we'll meet next week, inshallah. At the same time, is it good for you? At 2:30. السلام عليكم.
عليكم السلام.
دكتور.